Hello. Here we come to the unit of this class where we start by discussing clouds and then start discussing some general issues of the data deluge. Here was the slide we ended with last time, which was the last effectively data application, big data application, which was discussing the Internet of Things and the fact that those things will be controlled by the cloud and sensors and things are a pretty similar general concept. So now we're coming to clouds. And clouds, as we discussed, are very important as they are the back end that naturally controls both the things which we just discussed and all the processing of big data. This slide is from Microsoft Dennis Gannon and shows some of their data centers across the world, which Dennis points out that they have 100 data centers, Microsoft, across the world, varying in size from small ones to large ones, which are in the size range of 100,000 to 1 million servers. And both the global distribution and particular examples are shown here. I've pointed out already that when you go to the internet, you can find lots of information. But to decide how reliable that information is and get exactly the right answer is often not so easy. And things like the sizes of cloud data centers is viewed as proprietary, and there is not so easy to find reliable information about that. And so here we just take these slides from Dennis Gannon and take them as I don't actually have independent confirmation that there are data centers with 1 million servers. So one particular picture here, which is shown in expanded, is that of the 4th generation data center, and we will discuss those in just a tiny bit more detail as they illustrate some of the issues of clouds. So clouds are of course important here because they are the natural processing places of big data. They're sort of natural because big data was first highlighted by those what you might call the Web 2.0 or internet applications such as search and social networking and e-commerce. And clouds were developed first to process this data, and then starting with Amazon, it was realized that these facilities, which were being built to process this enormous amount of internet data and internet transactions, could be used more broadly, and uh, that sort of introduced the concept of public clouds and the fact that clouds can be used generally. And now it's sort of become a technology for data centers. So clouds have revolutionized the technology for data centers because they have introduced much larger data centers. And so in going to much larger scale, they've looked at the issues of efficiency and optimization that have not had such a strong focus in the past. This slide also is from Dennis Gannon, and it makes a sort of simple point that, but critical point that the reason why clouds are clouds and is that there are economies of scale by putting all the computers together. So the essential idea behind the cloud is that the internet allows us to access computers wherever they are. So we could do what was the grid, which is to say, so what we'll do is we'll take computers, scatter them across the globe, and then use the internet to integrate them together, and then we get some giant computer. So that's one actually relatively important view. But clouds are a little different. They say we can also take individual locations and put huge numbers of computers at that one location and then get an economy of scale in running that location. That location both has economy of scale from the fact that it is you don't need you can save on just the number of people required to manage the system. If you have 1 million computers in one place, probably does not need 10 times as many people to run it as if you have 100,000. You can also be careful to place these clouds in locations where the cost of energy is low and maybe it's particularly environmentally friendly. So if we look at the bottom uh, right of this slide, then it points out that these cloud centers are pretty big, some 10 or factor of 10 or more bigger than a football field. And then if we look at the bottom left, it has a table which points out how the cost of a large data center compares to the cost of a small data center, showing there's some factor of 5 to 7 depending on what you're looking at. So note that this points out some important issue that often when you think about buying a computer, you just look at the cost of the hardware. So that's the upfront cost. But if you're actually running a cloud, you're looking at both the cost of the computer and the cost of running the computer. So clouds don't particularly change the cost of the computers, although if you buy them in huge volume, you can presumably get a better price. But more importantly, they affect um, the actual lifetime cost of running the system, the the power, the and things like, and the actual people and things like that. So here's just a picture of a Google facility on the Columbia River, and it points out that these centers use quite a lot of power. Maybe the big cloud centers use from 20 megawatts. That's hundreds of thousands of servers to 200 megawatts, which is certainly what you might need numbers like that for million or millions of servers. So this slide here is a somewhat old slide with a quote from Microsoft, a press release about their Chicago facility, and it points out that one of the technologies used is a modular technology, which is actually expanded in their fourth generation data center, which says that you build data centers not with the unit being the rack, but the unit being a shipping container. And you just buy your computers in shipping containing units. Those shipping containers are transported to your data center. They're unloaded there, plugged in, and then you just get more computers. And so this particular Chicago facility has somewhere, it says here, from 150 to 220 shipping containers. And the picture here, these little rectangles are in fact, or cuboids are in fact shipping containers used in this particular facility. Um, Related to this, I've already pointed out environmental issues. So we can do two things. We can both position the cloud in a place that has environmentally friendly and cheap energy, but we can also design it in a way that is extremely efficient. And some measure of efficiency is the so-called PUE, which is the total power used in the facility divided by the power needed to run the computers. And if you look at what that is historically, it was actually pretty large. This number PUE was around 3. Now the average is meant to be 1.8 as people have become more efficient. But clouds can get that down. The best clouds can get that number down to 1.1 to 1.2. So this is what I pointed out. Clouds are revolutionizing data center technology. And one of their revolutions is to make those data centers just much cheaper, significantly cheaper to run by just being more efficient about the use of power. And another important issue is just the modularity. So in the fourth generation data centers, which were shown on the previous but one slide, uh, the they are basically making everything modular. So that I give a link here to show in more detail, not just the container-based search, everything is modular. So that when you want to expand it, you just make everything, all the network interconnects, everything is just modular. So you just can build your upgrade your cloud center in a very simple fashion, which is linear in the number of computers you want. You don't invest a large amount of money in a data center, make it empty for a long time, and then expand it. At some time, Microsoft has pointed out that one important feature of clouds as a computing paradigm is that clouds are so large, they focused a lot on reliability, because if you have a lot of computers at any one time, one of them is going to be broken.